All right, if you have questions about homework from yesterday, just hold on to them till tomorrow. Remember that? Yeah. Obviously, I can't answer them right now. So I'm just going to go over the stuff I wanted to do yesterday right now. Then the first thing was just my way, how to memorize the unit circle. I know Brenda and Carolina and Tanya have their finger thingy they're doing. I don't know that. If you want to know that, ask them. I kind of want to know. So maybe I'll ask them tomorrow when I get back. But here's my way. So things you need to know are all the angles. Well, not all the angles. I mean, it's just 0, 30 degrees, 60 degrees. No, 30, 45, 60, 90. That's it. That's in degrees. But you got to know what they are in pi. That's just fractions and knowing fractions. And if you know that this is 0 degrees, and if I go back around, this is 2 pi, right? You got to know 2 pi in a full circle. If you don't know that, then that's too bad. So if a full circle is 2 pi, you should know that a half a circle is pi. And if a half a circle pi is pi, half of that half should be pi over 2. And if you do 1 1/2, you got to know the fraction. Can you do a fraction of 1 1/2, but not put 1 1/2, like an improper fraction? That's 3 pi over 2. So there's that part. And now, 45-degree angle. That is, well, from 0, what's half of pi over 2? It's pi over 4. And you can go around and put all those on there if you want. So pi over 4, and then you get pi over 2. What's going to come next? It's tricky. Yeah, I know it's tricky. Well, just think of like a quarter. You have a quarter, now you have 50 cents. Hey, now you have 75 cents. 3 pi over 4. But then you got to keep going. So these are just all the quarter angles, these are all the 45s, basically. Notice pi over 4, another pi over 4, 3 pi over 4. This would be 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. This is just fractions. This isn't memorization. So this angle right here, that's like a 30-degree angle. That's, a 30-degree angle is 1/6 of 180 degrees. So 1/6 of pi, hey, that's pi over 6. All right? And if I double that and I go to a 60-degree angle, 2 pi over 6, well, 2 pi over 6 reduces to pi over 3. Right? So then just keep going with your fractions. I lost my train of thought there for a second, sorry. So I'll go to here. I don't know, is this what your finger thing does? Is this? I don't know what it is. You don't really need to even memorize. I don't even know if you need to memorize these. But you need to know the sines and cosines of all these. And that's where the memorization part comes in. So that's 5 pi over 6. Then we got a full pi. Right? I'm just going by sixths. These are going by sixths. Anyway, don't worry about that. Sines and cosines, that's where the important part is. So if I want to know the sine and the cosine of each of these, remember, cosine is x, sine is y. Talked about that yesterday with either sinning and going to heaven and hell. That's why you get the sine of theta as y. Or if you're alphabetical, you can do it that way too. There you go, Shania. Happy. So sine and cosine, I start with the pi over 4 right here. Really, all you need to do, if you can memorize the first quadrant, the rest, there's a pattern. And you'll see it real easy. I've got all these in here. Let's see, 7 pi over 6. I don't feel like writing these. I hope no one's trying to write this down as I do this. This is just the unit circle. You could literally just be looking at it. What's this? 5 pi over 3. I'm kind of just testing myself. Pi over 6. All right, so sine and cosine of them all. Focus on the first quadrant. I mean, this is literally if you had a blank one and you're trying to figure it out. If if it's a 45-degree angle, the sine and the cosine are the same, because if you drew a triangle that was a 45, 45, 90, these sides are the same. And well, just a bit of memorization would tell you that it's root 2 over 2 and root 2 over 2. And they're always going to be the same on all of the 45s. So this one's going to be root 2 over 2, comma, root 2 over 2. Then you just got to get the positives and negatives. Well, in this first quadrant, x is positive and y is positive. And over here, you're going to have a negative x and a positive y. So this will be negative root 2 over 2 and positive root 2 over 2. Down here, right here on this one, you're going to have a negative x and a negative y. So now they're both negative. See how easy this is? And here, positive x, negative y. So you got positive x root 2 over 2 and negative y, negative root 2 over 2. That's memorize it. Let's say you freak out and you can't remember, like, crap, is it root 3 over 2? Is it root 2 over 2? And I'm trying to do the 45. Well, think about a 45, 45, 90 triangle. Radius is 1, so these are the same. So we'll call it x and x. Well, now if I do Pythagorean theorem, x squared plus x squared equals 1 squared. Well, x squared plus x squared, that's 2x squared. Okay, sorry about that. Where were we? 2x squared equals 1. This right here, we were solving for x, so we'll divide by 2, so x squared is a half, and then you square root it, and then you go x equals, well, the square root of a half, I don't know, but I know square root of 1 over square, you can do that, right? So the square root of 1 is 1 over the square root of 2, but then I can't have a square root on the bottom, so I go root 2 over root 2, and then, oh yeah, okay, it's 2, oh, okay. Or you could just remember, think about it, memorize it, to get root 2 over 2. That's the long way. But it's possible. I mean, if you completely blank out and you got to just sit there and do the math, you can figure it out. So that's our root 2 over 2's all the way around. Right here, you could do the 30, 60, 90 specialty way like I just did here, but no one's going to do that. No one can just bust that out probably. So you just got to remember. So this point right here, if you just remember this one, you can get the rest. So this one is root 3 over 2 and 1/2. If you just remember that one, I think that's what their finger thing means. It might be that. I don't know. Well, this one, now, this 60-degree angle, those just switch. So it's 1/2 and root 3 over 2. So now going around the circle, all these just repeat, right? So if you come over to this one and this one are going to be the same thing, just with negatives. Because see how this one's only like 30 degrees up from horizontal, so is this one. So your sine and your cosine are going to be almost the same thing. So here, instead of root 3 over 2, it's going to be negative root 3 over 2. And 1/2, right? And you can do this all the way around. This one, they're just going to switch. So now, whoops, I switch signs. So your x-coordinate will now be, instead of 1/2, now you're going to have negative 1/2. Right? And I can go through and show you. You can see the pattern. See it? Root 2 over 2, the reds. Look at this one. I printed this one because it's in color because you can see it. You can see easily the 45s, 135s, pi over 4, 3 pi over 4, 5 pi over 4, 7 pi. Those are the 45s. Both x and y positive, negative, right? You see it? I mean, I can help you out more with that later, but you need to start knowing so that if you see, the reason you need to memorize this is not just for the sake of memorization, but so if you have a problem, you're working on it, and you see the sine of pi over 3, you should be able to figure out the sine of pi over 3 without looking at this. And you should be able to figure out that it's root 3 over 2. And just by drawing yourself a sketch or some method, I don't know, I guess I need to learn the finger thing. But you need to have a way of busting that out, because there will be a no calculator section on the AP test, and there will be trig on it. So you'll have nothing to look at and no calculator, and you'll have to know what the cosine of 4 pi over 3 is and be able to come up with something. I mean, that's not going to be the question. That'll be within a question. But if you don't know that piece, you won't be able to move on to do the actual calculus. The reason I say no calculator, on the calculator section, of course, there are ways we can figure all this out later. But you can program stuff in. You can like create programs and type like unit circle in and have a way to look it up. Or I'm an idiot. Or you could just freaking type sine of 4 pi over 3. Duh. Anyway. Ooh, it's getting late and I want to go home. That's memorizing the unit circle. You can start working on that. Start thinking about that. Like I said, look at it every day. Get it tattooed on your arm if you want. Actually, I don't recommend that. It's pretty dorky, but okay. I'm taping my paper down so it doesn't move while I'm writing. Next, we're going to graph. Your favorite thing, graphing. So like graphing the f of x equals the cosine of x. We'll start with cosine. So what does the graph of cosine look like? And we're going to do it in radians, of course, because doing it in degrees makes no sense. So I'm going to draw my x and y axis here. Before I set this up, let's think about domain. I don't know if you can think about domain yet. Maybe you can. What can I plug in here to where I'll get an answer? Meaning, what numbers can I plug in for x and I'll get an answer for y? Well, if you think about the unit circle, the stuff you'd be plugging in for x are the angles, right? So if you think in radians, all the pi ones all the way around, and does it stop or can I keep going? Good, yeah, I can keep going. Right? I can go round and 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 round. So for x, it doesn't matter what I plug in. I can go as big as I want. I'm just going around the circle more times, right? And I can go this way too. I can have negatives because I can go this way around the circle, right? And this negative is just direction. So my domain is all real numbers. But I'm not going to graph this huge thing. I'm just going to grab a portion of this because this does go forever to the right and to the left. And really, you don't even, I was just going to say, you probably don't even need to be writing this down. Probably just listening and taking it all in would be more beneficial because there's pictures of this. You can look up a picture of a cosine graph. You don't need to draw one yourself yet. So let's think about plugging numbers in here. What's going to happen? If I plug in 0 for x, what's the cosine of 0? Well, here's 0. Cosine, remember the x value, it's 1. So the y-intercept is going to be 1. Our domain was all real numbers. Let's think about range real quick. Well, not yet. I don't know what's going to be easier to think about first. So 1, now as I go around here, I'm just going to plug in easy ones. Like, I'm not going to plug in, I plugged in 0 for x. Now I'm just going to pick beneficial things for x that I think I can figure out. What do I know the cosine of? Well, how about all these? So can I plug in pi over 6? Yeah, but that sucks. I don't want to graph root 3 over 2 or root 2 over 2. Hey, pi over 3 is 1/2. Hey, pi over 2 is 0. Those are the easiest one. I'm going to go, my x-axis, I'm not going to go like 1, 2, 3, 4, 5. Instead, I'm going to go, here's pi over 2. Here's pi. Here's 3 pi over 2. Here's 2 pi. Right? Those are just numbers. I can go by whatever I want on my axes. It doesn't matter. Here's negative pi over 2. So in this case, I'm going by pi over 2's. So I know the cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Oops, I said we were going to think about range. Cosine of 3 pi over 2 down here is 0 again. That's weird. Cosine of pi over, or 2 pi is back to 1. Back up here. Well, guess what? Isn't it just going to repeat? The cosine is the x value of these angles, right? Well, isn't the highest x value possible 1? and the lowest x value possible is -1, that's our domain and range right there. Our range, it's never going to go below -1, and it's never going to get above 1. And it's just going to repeat, as I keep going now beyond 2 pi, it's just going to repeat over and over again. You could get some intermittent values here, like pi over 4, and if you do that, cosine root 2 over 2, and if you do root 2 divided by 2, you get 0.707, so it's like up here somewhere. But what these turn out to be are these nice curvy waves. And it does that forever and ever and ever. You've probably seen this before. That's a cosine wave. And they go forever like that. The reason I said don't write it down, they're in your book. Nice. Here's a cosine. If you do sine, it's the exact same thing, except instead of, the only way you can tell a sine and a cosine different, cosine, the x-intercept is 1, because the cosine of 0 is 1. That's one of the key ones. That's the one you should memorize first. You should know the sine and cosine of 0 degrees, or 0 pi, or 0 radians. So, I mean, draw it if you want. Here's 0. Cosine of that is 1. The sine of that is 0. Right? That's a 0 to 0 radian angle. There's your first one you absolutely need to memorize. What are the sine and cosine of 0 radians? Cosine is 1. The sine is 0. So like for the sine of x, the y-intercept, plug in 0 for x, the sine of 0, the y-coordinate is 0. So it's going to start right here. But it's also going to do this same wave thing. It just starts at 0 instead of up at 1. And that is shown right here. Tangent's kind of tricky. You might think, well, why does it look like that? Well, because you're dividing tangent opposite over adjacent, remember, y over x. You're dividing sine divided by cosine. I guess I should have thought. I don't know how in-depth I want to go into this, just of why it looks like the way it does. Think about this. If you do the tangent of 0, that's 0 divided by 1, right? So that's 0. The tangent of 0 is 0. But when you get around to pi over 2, what happens? You know, tangent of this, y divided by x, well, you got 1 divided by 0. You can't do that. You can't do 1 divided by 0. That's why there's a whole bunch of asymptotes like this. These pink lines are the asymptotes. That's where you get your divide by zeros. And it's also cyclic. It repeats. It's periodic. That's a better word. So you get this little funky thing here, and then there's an asymptote where you get divided by 0 and you can't do it. So that's tangent. Inverse sine, or secant, remember, it's just 1 over cosine. So if I do, like, if I went point by point here, we could do 1 divided by 1, like right here. 1 divided by 1 is 1. And then as you go down, as this number approaches 0, if I go 1 divided by these numbers that approach 0, this is going to get really big. But then when this one hits 0, 1 divided by 0 is nothing. There's asymptotes there. And so you get these funky little, almost parabola-ish things. Like if I drew this one right on this one, where's my pencil? Here's the cos graph. The secant graph would look like this. Right off these, it would be like this. Because you're just taking whatever this cosine is and doing 1 divided by those numbers, and so you're getting these weird things right here. So like right here at 0, when the cosine is 0, this one's not going to exist. As it approaches 0, this one gets really, or I should do the positive way. As the number I'm dividing by gets really, really small, doesn't my y value get really, really big? Like if I'm having 1 divided by x, if x is getting smaller, this is getting bigger. So as this gets small, this gets big. That's why this is there. I know I'm kind of rushing through this. You guys are probably like, I'm really rushing through it, but that's just the way it's got to be because we're half a year behind. so we're not going to go too in depth. So there's what's that, cosecant and then cotangent. Kind of just flips that one. So the big thing is just, can we graph them? that's what they look like in general. So let's talk about some key things to look for on the graphs. I'll do that right now. So like the general equation for a sine or cosine function, you know how before we had a times x minus h squared plus k. For a parabola, that a, h, and k stuff, yeah, similar stuff here. Similar but different. So we're going to have a times the sine of 2 pi divided by b times x minus c plus d. So it's just slightly more complicated than before. So these letters A, B, C, and D do some shifting to those cos waves and sine waves that I drew. But they're pretty similar to before. You can probably guess what A is. A, well, I should draw here. We better draw a picture over here. And since this is sine, we better actually draw the sine wave. We'll just I'm out of room. Goes on forever. So A is the amplitude. All the amplitude is a measure of how tall the hills are, basically. So from here, and you just go from the x-axis up to the peak of one of the hills. That's your amplitude. Or you could go from the x-axis down to the bottom of the hill. That's your amplitude. So on the regular old sine graph where A is 1, the amplitude is 1. How tall the hill, that dotted line there represents the amplitude. If you put a 2 in front, these hills get taller. 3 in front, they get tall. Put a fraction in front, like a half, the hills get smaller. So it's how tall the hills are, basically. That's your amplitude. B determines your period. These are called periodic functions, meaning they repeat. Periodic is something that happens every so often. The period is how long it takes to repeat. So in this case, the period, like let's say we start here we can start at 0, and well, no, I shouldn't start at 0 because that gets confusing. So the period of this, we'll start at the top of a hill. So how long does it take till we hit the top of a hill again? That's the period. Label amplitude. That's the period. That's how long it takes to repeat. In the case of just a regular old sine graph, where b is 1, say I wrote 2 pi over b. Oops, that's kind of, I confused myself. This book does it weird. I just copied this equation out of the book. B is not the period. 2 pi divided by b gives you the period. B is the number that changes the period. Anyway, it doesn't matter. I just confused myself. The period on a regular sine graph is 2 pi. It takes 2 pi for the thing to repeat. Every 2 pi you go, it repeats, just like we've talked about. If I just keep adding 2 pi, I get the same thing for the sine and cosine, right? So like if you look on here, top of the hill's at pi over 2. The next time I hit pi over 2, or the next time I hit the top of a hill, will be at pi over 2 plus 2 pi. Whatever that is. It's 5 pi over 2. No? Crap, I don't know. My brain's not working right now. But if I look at 0, the reason I said I didn't want to pick 0, because it gets confusing, is you might think it repeats again right here. Well, it's got to be on the way up. That's not a repeat of that. So it takes, the period is until it gets here. So from 0 to 2 pi, hey, it'll start repeating again, because 2 pi is the period. I'll explain that in a minute when I actually graph one. C Well, just like before, the thing, remember we had x minus h and that shifted left and right? Yeah, C does the same thing. It's horizontal shift. Also called phase shift, but don't worry about that. And then D is the same as before. The thing you had on the end is up and down, so it's your vertical shift. So I think this would just make more sense, especially that B thing where I confuse myself. If I actually just do an example, if I'm capable of that right now, let's see. Yeah, this is why I'm an idiot. Oh, whoa, this thing's freaking out. I was just showing the clock. It's like almost 6 o'clock. Let's see. I had an example I wanted to do. There we go. Graph y equals 3 times the cosine of 2x minus pi plus 1. Oh, I see why they did the B thing the way they did. This actually makes more sense. So the first thing you want to do when you're graphing these is figure out all these parameters. Figure out your amplitude, your period, if it's shifted left or right, and it's shifted up and down. It makes the drawing of the graph way easier before you start plugging in numbers. 'Cause that's all you're going to do. You're going to figure out these 4 things, and then you're going to start plugging in values for x. And that's it. So here we go. Let's start. Amplitude. This one should be easy. There's a 3 in front. That's your amplitude. It's 3. So you know now when you make your y-axis, you need to go up to 3 and down to -3, because that's the high. Well, maybe. Actually, I take that back. Because it is shifted vertically. But right, if that wasn't there, the amplitude means it would go up to 3 and down to -3, right? And it would go wee. But I wasn't going to do this next, but kind of led me there. Our vertical shift is up 1. So our center, we kind of have like a center line through these where they kind of oscillate up and down around. That's going to be shifted up 1. So now that center is going to be up here at 1, which means with my amplitude now, I'm going to get up to 4. So really what this is going to end up looking like, here's 1. It's going to be kind of my center line. So I'm going to go up to 4 and down to -2. And that's what, just a rough sketch of where I'm headed, right? Makes sense? The center line's there. The amplitude is the distance from the center line up to the top and bottom of the hill. I think earlier I said x-axis. It doesn't have to be the x-axis. There's always kind of a center line there. They're always symmetric. Okay, so we got our amplitude. Let's figure out our period. And this is the weird part, which up until looking in this book, I've never seen it done this way, but this makes it way easier. So they gave you in parentheses just an x minus c. There's no number in front of the x. This has a number in front of the x. So the way they take care of that here is factor out that number in front of the x right there. So just think, I wish I had another hand here. Just look at that piece, and now I have 2x minus pi. If I factor a 2 out, what will I have? Well, what I mean by that is, if I take the 2 out, if I take a 2 out of 2x, what's left? Or 2 times what gives me 2x? Just x. Minus 2 times what gives me pi? Don't think too hard. It's pi over 2. Right? And then the rest of the stuff's this. I'm talking too much. iPad ran out of memory, but it's kind of good that it did, because I decided I don't like this. See, I've always learned, I didn't even do this factoring crap. I've always learned to find the period, you take 2 pi and divide it by whatever the number in front of the x is. So in this case, 2 pi divided by 2, pi. Boom, found the period. Easy deal. This way, this factor way, I don't know, it just adds a complication into it, and then writing the 2 pi over the b out front in this equation, I decided just going over this, I don't like it. Like, I wish I would have thought about that before I made all these notes. So I think we should just do another one and scrap this one. Or we could just finish. Anyway, so we got to figure out our horizontal shift and vertical shift. I guess writing it this way makes the horizontal shift easier, but the period harder to figure out. Doing it my way makes the period easier, but the horizontal shift harder to figure out, I guess. But the period's more important if you're going to draw a graph by hand, because the horizontal shift you can figure out just by plugging in numbers. So, yeah, I'm rambling. I don't want to finish that one. Just pick it up. I'm just going to go to your homework and pick one. Or I can just make up numbers. Let's see. Where is the homework? 17. So like number, we'll just go like this. We'll just do 3 times the cosine of 3x plus pi minus 1. Good enough. Just made it up. So graphing it. I'm not going to do the weird factoring way. I'm just going to do it my way. I'm not going to try to follow your stupid book. Amplitude. Just the number in front. It's 3 again. Hey. Let's go ahead and do vertical shift right now. And let's set up our axes. That seems to be the easiest. It's going to be down 1, right? The negative 1 back here is down 1. So now let's set this up here. Draw this. It's down 1, so your center line is going to be down here at negative 1. I like to just put myself a dotted line here so I know that I'm going to be oscillating around that dotted line. Amplitude's 3, so 1, 2, up at 2, that's going to be my highest, and down 1, 2, 3. So down at negative 4, that's going to be my lowest. So there's my range right there. From, your domain, of course, is all real numbers, and your range from negative 4 up to 2. So now let's figure out the period. My way is I always just learn 2 pi divided by whatever the number in front of the x is, which is easy. In this case, 2 pi divided by 3. I don't do this. They do 2 pi over b and then say b is the period. But to me, that's weird. 2 pi divided by, I don't know. This is just weird. So just do 2 pi divided by the number in front of the x. You get your period. So my period's 2 pi over 3. That's going to make it tricky to graph, but that's okay. So whenever you figure out your period, to graph it, which you're only going to have to graph 2 of these, take half of your period and go by that on your x-axis. Actually, probably a quarter. So half of my period, half of 2 pi over 3 is pi over 3. So I'm going to go by pi over 3s. So here's pi over 3. Here's 2 pi over 3. And then I'll have pi over 3, 2 pi over 3. What's next? Pi. 4 pi over 3. I'm going by pi over 3s. And I told you horizontal shift, that can be tricky. So at this point, I would just plug in numbers. If I plug in 0, where am I at? Plug in 0 for x, 0. That's 0. So I have the cosine of pi. So I have, and this is really the only reason I wanted you to do this, is to get used to plugging in numbers. So if I plug in 0 here, so f of 0, I have 3 times the cosine of 0 plus pi. So 3 times the cosine of pi minus 1. Well, cosine of pi, you could use your calculator and type cosine of pi in having it in radians. But that one's easy. You should be able to know, hey, pi is over here. The cosine of that is negative 1. So this is negative 1 times 3 minus 1. That's negative 3 minus 1. I get negative 4. Boom, I have my first point. Now that I have my first point, I also have another point. If I know my period's 2 pi over 3, that means it repeats every 2 pi over 3. So here's the negative 4. That means that at 2 pi over 3, I'm going to be back at negative 4. At 4 pi over 3, I'm going to be back at negative 4. All right, so those are going to be the bottoms of my hills, for lack of a better term, I guess. And really, I can almost do everything now. Right in the middle, these are always symmetric, so these are going to be the bottoms of my hills. And they're going to peak right in the middle, so at pi over 3, I'm going to be at my highest point. And we could check that, and we can plug in pi over 3, maybe we should. F of pi over 3 equals 3 times the cosine of 3 times pi over 3 plus pi minus 1. Well, 3 times pi over 3 is just pi. Pi plus pi is 2 pi. The cosine of 2 pi, without a calculator, it's right here, that's 1. So I have 3 times 1 minus 1, that's 3 minus 1. I get 2. Hey, I was right. It's up at 2. Well, so at this point, you can almost just draw the thing. You could plug in some more points if you want, but that's pretty much good enough for me. It's going to be at pi over 3. It's going to repeat again here. Good enough. Figuring out those 3 things is the most important. Okay, so I just decided I'm going to take one of them off your homework because you don't need to graph 2. If you can just graph one of them, figure out the amplitude, figure out your vertical shift, draw your center line, set up your y-axis, figure out your period by doing 2 pi whatever divided by whatever the number in front of x is. Up here it would have been 2 pi divided by 2. We would have got pi. So if we were setting this one up, we could have gone, I would go by pi over 2. So go pi over 2, pi. Right, and then it's just a matter of plugging in a few of these numbers for x, getting your y values, putting the dots on there. If you know the period, you know where they're going to repeat. Hopefully I have thoroughly confused you. I like when you guys ask questions the next day. So there's that, but I told you only one graph, so we'll delete 12 or 14. Let's see which one looks harder. I don't know, they look the same. So we'll just get rid of 14. So just do that. And I'll hold it here so you don't have to pause it. But then it'll take longer to upload. Better pause it. See you tomorrow.